question is whether a 10-degree kick or offset in a conduit run at a box or panel counts towards the total of 490-degree bends, which equals 360 degrees. The answer is no. According to electrical codes and best practices, a minor kick or offset, such as a 10-degree bend, is generally not considered a bend that contributes to the maximum bend allowance. The purpose of limiting the number of bends in a conduit run is to prevent excessive pulling force on conductors during installation. Excessive pulling force can damage the conductor insulation, leading to potential electrical faults or failures. The National Electrical Code, or NEC, specifies limits on the number of bends to ensure conductors can be easily and safely pulled through the conduit. The code typically allows for a maximum of 360 degrees of bends between pull points such as boxes or conduit bodies. This limit is designed to minimize friction and stress on the conductors. Now let's delve deeper into why a small kick like 10 degrees is not usually counted towards this limit. Firstly, the impact of a small kick on the pulling force is minimal compared to a full 90-degree bend. A 90-degree bend significantly changes the direction of the conduit and therefore the direction of the conductors being pulled through it. This sharp change in direction creates substantial friction. Secondly, small kicks are often necessary to align conduit with enclosures or to navigate minor obstructions. If every small kick was counted towards the 360-degree limit, it would severely restrict the flexibility of conduit installations and make it difficult to achieve proper alignment and routing. Thirdly, the NEC and other relevant standards focus on bends that materially affect the ease of pulling conductors. A 10-degree kick is unlikely to cause a noticeable increase in pulling force. However, it is important to consider the cumulative effect of multiple small kicks. While a single 10-degree kick may not be significant, several such kicks in close proximity could collectively contribute to increased friction. In such cases, it is wise to evaluate the overall bend and consider whether it is approaching the limit. Here are several factors to consider when evaluating conduit bend. 1 is the conduit size. Larger conduits can generally accommodate more bends or sharper bends without significantly increasing pulling force. Smaller conduits are more susceptible to friction from bends. Another factor is the type of conductors. Conductors with low friction insulation, such as those with a Teflon coating, can be pulled through conduits with more bends compared to conductors with standard insulation. Thirdly, the pulling lubricant can significantly reduce friction during conductor installation. Applying a high-quality pulling lubricant can make it easier to pull conductors through conduits with multiple bends. Here are some best practices for conduit bending and installation. Firstly, always use the correct bending tools and techniques. Proper bending tools ensure that the conduit is bent smoothly and without kinks or deformations, which can increase friction. Secondly, plan your conduit runs carefully to minimize the number of bends. Consider using offsets, saddles, and other bending techniques to navigate obstacles while keeping the total bend angle within the limit. Thirdly, when practical, use conduit bodies or pull boxes to break up long conduit runs with multiple bends. Conduit bodies provide access points for pulling conductors and can significantly reduce the overall pulling force. In summary, a 10-degree kick in a conduit run typically does not count towards the 360-degree bend limit. However, it's crucial to consider the cumulative effect of multiple small bends and to adhere to best practices for conduit installation to ensure conductors can be pulled safely and easily. Always consult the latest edition of the NEC and local electrical codes for specific requirements and interpretations. If in doubt, consult with a qualified electrician or electrical inspector. Let's explore further the specifics of conduit bending and the impact of different bend angles on conductor installation. When bending conduit, it's important to understand the mechanics of bending and how it affects the conduit's internal diameter. Excessive bending or improper bending techniques can cause the conduit to flatten or kink, reducing its internal diameter and making it difficult to pull conductors through. Conduit benders are designed to distribute the bending force evenly across the conduit, preventing deformation and maintaining the conduit's circular shape. There are several types of conduit benders available, including hand benders, hydraulic benders, and electric benders. Hand benders are suitable for small diameter conduits and relatively simple bends. Hydraulic benders are used for larger diameter conduits and more complex bends, as they provide greater bending force and control. Electric benders automate the bending process and are ideal for high-volume applications. Now let's discuss the different types of bends commonly used in conduit installations. Firstly, we have 90-degree bends, which are used to change the direction of the conduit by 90 degrees. These bends are typically used to transition from a horizontal to a vertical plane or vice versa. Secondly, we have offsets, which are used to move the conduit parallel to its original path. Offsets are often used to navigate obstructions or to align conduit with enclosures. Thirdly, saddles are used to cross over obstacles such as pipes or other conduits. Saddles consist of two offset bends that bring the conduit back to its original plane. Fourthly, segmented bends are used to create large radius bends. Segmented bends are made by making a series of small, closely spaced bends. Fifthly, kicks, as mentioned earlier, are small bends used to slightly change the direction of the conduit. It's also important to understand how to calculate bend angles and conduit lengths accurately. Accurate measurements are essential for creating precise bends and ensuring that the conduit run fits properly. Conduit bending software and calculators can assist in determining the correct bend angles and lengths. When planning a conduit run, consider the following factors. Firstly, the shortest path between 2 points is not always the best path. It may be necessary to route the conduit around obstacles or to follow existing structures. Secondly, avoid sharp bends and abrupt changes in direction. Use gradual bends and smooth transitions to minimize friction and stress on the conductors. Thirdly, support the conduit properly to prevent sagging and movement. Use conduit hangers and support spaced according to code requirements. Fourthly, seal the conduit to prevent moisture and contaminants from entering. Use conduit sealing fittings and sealants to protect the conductors from corrosion and damage. Furthermore, let's discuss the different types of conduit and their applications. Firstly, rigid metal conduit, or RMC, is a heavy-walled conduit typically made of steel or aluminum. RMC is used in applications where high mechanical protection is required. Secondly, intermediate metal conduit, or IMC, is a lighter weight conduit than RMC but still provides good mechanical protection. IMC is often used in commercial and industrial applications. Thirdly, electrical metallic tubing, or EMT, is a thin-walled conduit that is easy to bend and install. EMT is commonly used in residential and light commercial applications. Fourthly, flexible metal conduit, or FMC, is a flexible conduit that is used in applications where movement or vibration is present. FMC is often used to connect motors and other equipment. Fifthly, liquid-tight flexible metal conduit, or LFMC, is a flexible conduit that is covered with a liquid-tight jacket. LFMC is used in wet or damp locations. Finally, non-metallic conduit, such as PVC conduit, is used in corrosive environments or underground applications. PVC conduit is lightweight and easy to install. Always select the appropriate type of conduit for the specific application based on the environmental conditions and mechanical requirements. In addition to the NEC, other standards and regulations may apply to conduit installations. These may include local building codes, industry standards, and manufacturers' recommendations. It is essential to be familiar with all applicable requirements and to follow them carefully. Proper conduit installation is critical for ensuring the safety and reliability of electrical systems. By understanding the principles of conduit bending, the types of conduit, and the applicable codes and standards, you can ensure that your conduit installations are safe, efficient, and compliant. Remember that working with electricity can be dangerous. Always take appropriate safety precautions and consult with a qualified electrician if you have any questions or concerns. Finally, always double-check your work and test the installation to ensure that it is functioning properly. It is prudent to ensure all connections are tight and that all grounding and bonding requirements are met. A final inspection helps ensure the long-term safety and reliability of the installation. When planning any conduit run, it helps to sketch out the run on paper. This gives you a bird's eye view of the run. This visualization can help ensure you are not exceeding the number of bends. Also, visualizing the run helps you think about the location of pull boxes or junction boxes. It may seem more efficient to make the run without any J boxes, but it may be necessary to make the run code compliant. Pulling wire can be difficult in tight spaces, so plan to locate the pull boxes in a location that is accessible. When making bends, the type of bender used matters. A high-quality bender will prevent kinks and dents. Dents and kinks will make pulling the wire difficult and possibly damage the conductors. There are many online videos that can show you the proper way to use a bender. This can save you conduit and money. It's better to watch someone else mess up than to do it yourself. Finally, don't be afraid to ask for help. If you are unsure about something, ask a qualified electrician or electrical inspector. They can help you avoid costly mistakes and ensure that your conduit installation is safe and compliant.